Right, previously I made a video to show you how to hack this solar powered floodlight that you install outside of your garage or your door. But the problem with this setup is this battery produces 6.5 volts, and even though it's got a circuit board here, it does not limit the voltage down enough. So 6.5 volts is charging this battery pack at 5.5 volts, and between 5.5 and 6 volts. So this battery pack here has been receiving 5.5 volts, and these kind of battery only take maximum 4.2 volts max. At 4.2 volts max, it's very sensitive to higher voltage, and I've run it for like a week or so, and it just killed the battery. Been running at this voltage, and it just killed both of these batteries. They're in parallel, so they say at 4.2 volts, because the solar panel produce so much voltage, a lot higher than what it can handle, so it just died. Both of them died. So now I'm gonna have to replace this battery and try a different method. So the way I'm gonna do it is I'm gonna cut the connector of the solar panel, and I'm gonna install a resistor and a diode, and I will show you in a little bit. So next I need to put in a resistor to limit the voltage going to the battery, and the way to calculate it is I'll show you what I got here. So the solar panel produces 6.2 volts open circuit voltage, and open circuit current is 0.14 volt. So I just put it under the sun and measure the voltage and the amp when it's not under load, it's not connected to anything. Okay, and I know the battery voltage cannot go over 4.2 volts. So what I need is to eliminate the difference between this and that. So the difference is 2 volts. So I need to eliminate 2 volts. So I need to use a resistor to solder into this circuit to limit the voltage to only 4.2 volts, right? So I need to take out 2 volts, and I'm use Ohm's law. So V equals IR. Therefore I need to find R, so I got R is V over I, and I want to take out 2 volts, so I got 2, and I know the current, the open circuit current going to the battery is 0.14 amp, so I've got 14.3 ohm, right? So I need a 14 ohm resistor, and let's see. Right, so I've got this resistor here, which is 18 ohm. Cannot find anything around 14, 15 ohm, but 18 ohm is good enough. I mean, it's even safer. So I got it soldered here to the positive line going from the solar panel. And the resistor doesn't have any polarity, so I can do it this way or that way, it doesn't matter. And the next one I have here is the diode. So the diode has to be in certain direction, in the direction of the current that's flowing. So you want to go power to go from the panel to the battery. You don't want it to go the other way around when the sun goes down, right? So you can see the grayish part here on the diode pointing toward the battery. So this is more like an arrow to me, so it's like this, so it's going that way, so I want it to go that way, right? So it's pointing toward the battery, so it only goes that way. So when the sun goes down, power doesn't go from the battery back to the solar panel. Without the diode, right, when the sun goes down, the power is going to go back from the battery. It's going to go back to the solar panel, and you're going to waste power, and more likely you're going to kill this battery too. Right, so I'm going to show you later on how that works, how the diode works. Alright, I got my solar panel here, and I got it's charging the battery, and I'll show you. So this part here is just the solar panel, and it's about 5.8 volt. Let me move over here so I can get more sunlight. Let's try again. .86 volt. That's before it gets to the resistor and the diode. So let's try the resistor, right? So from 5.86, when it passes the resistor, it becomes 5.5, so it's lost 0.36. Right? Now let's go to the diode. Let me switch the polarity here. Go to diode. It becomes 4.12. So the resistor here is effectively lowering the voltage down to only 4.12 volt, while over here, before it gets to the resistor, it's 5.8 volt. That's way over the voltage of the battery. Alright, so it's right now at 4.12 volt, and it's been charging all day, and it doesn't go past, I haven't seen it go past 4.2 volts. So it's perfect. This setup is perfect for this kind of battery, 18650. Alright, so let me show you what happens when the sun goes down. And right now I have all my lighting here so we can videotape this. So the solar panel is actually still producing some voltage. So let me simulate what happens when the sun goes down. So I'm going to cover up the panel, and let's see this here. Let's see. So the power now is going to go back from the battery back to the solar panel if you don't do anything, if you don't have a diode here. So let's see. 4.09 is the battery voltage right now. So from here to here, 4.09 volts. So let's see after it go past the diode. Actually nothing. So 0.01 volts. 0.01 volts. After the resistor should be the same. So there's nothing. It's effectively blocking power going back to the solar panel. So again, here is the battery before it goes to the diode. the battery voltage 4.09. After the diode 0.01. So it actually blocking all the power going back to the panel at night. Alright, so I've soldered everything back together, and let me show you the final product. And the light is working. Hoorah! So the solar panel go around, and this is the wire from the solar panel. The positive wire go to the resistor, and then go to the diode, and then go to the positive end of the battery. The negative wire from the solar panel go to the negative end of the battery, and from the unit, the positive end go to the red wire and go to the positive side of the battery, and the negative ends of the unit from the unit go to the negative end of the battery. That's pretty much it, and it's working, which is great. And let me show you lastly what happened to this battery pack when I overcharge it with this panel. Let's see. .3 volts. Same thing. Both of these are short. 0.3 volts. Absolutely short. So I believe what happened was the panel, the solar panel, put too much voltage on this pack, and then it just heat up and boil the chemical inside the solvent, the medium, whatever that is, inside this battery, and evaporate. It doesn't explode because this kind of battery got a vent on the top here, so it vents everything out without exploding. So right now there's nothing left, only 0.3 volts, which should be around 4 volts. Now it's only 0.3 volts. So that's what happened when you overcharge this kind of battery. And that's pretty much it. It's working now. Until next time, and thank you for watching.